Hello and good day, Algebra. We are kicking off Unit 8, which is all about quadratic equations. And the reason why we are talking about parabolas is we'll get right to defining it here. A parabola is the graph of a quadratic equation. Okay, the graph of a quadratic equation. So you've actually been working with quadratic equations for the last week and a half or so now, possibly even longer, because the standard form for a parabola, what a quadratic equation is y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c. Where have you seen that before? That form, ax squared plus bx plus c. Everywhere in the last week, because of what have we been doing? Blake? Yeah, on your test, because we were factoring, right? We were factoring. We were doing kind of that grunt work to prepare us for working with parabolas. And if you notice here, I mean, what makes an equation a parabola? If I take away that ax squared term and just write instead y equals bx plus c, what does that look an awful lot like? Slope-intercept form. Y equals, we don't call it bx plus c, we call it mx plus b, but without that ax squared term, we're right back to a straight line. So whenever you see an equation with that x squared term, that's what gives it that parabolic shape, that power of 2. Okay? If you were to change that to a power of 3, well, now your graph looks something else. An x cubed graph, you don't have to write this down, but an x cubed graph looks like this. Okay? So every kind of design for an equation has a graph that's associated to it. We've done mx plus b. Now we're doing ax squared plus bx plus c. Okay? And then this is what a parabola looks like here. It's a smiley face type thing, or if it opens downward, then it's a frowny face. But the domain of a parabola is the same as the domain for a linear function. The x values included in the relation, right? Same definition as we had for the domain of a linear function. All those x values that are included. And usually, unless you're dealing with like a contextual situation here, usually the domain is always going to be all real numbers. Okay? As we saw with linear functions, right? Because lines go on forever. So every x value at some point is included here. Same thing with the parabola. It kind of has that center point, which we'll get to in a little bit, but then it curves upward, and the arrows on each end tell us that it goes on and on and on, gets wider and wider and wider, and so every x value will at some point be included. Okay? The range would be what? Same definition as we had for linear functions. What was the range of a linear function? Yeah. The y values included. The y values included in the relation. The y values included in the relation. And if you remember, this one was also all reals for a linear function because a line goes on forever, and so all y values would eventually be included. Not so much for a parabola. Okay? Not so much for a parabola, because what a parabola does is, if we kind of start at the top here, the top left, and follow it down, we go down, we go down, we go down, but at some point we stop and we go back up again. Never to go down, right? So not every y value is going to be included in a parabola because it does not go up and down forever. It goes side to side forever, but not up and down forever. And we'll talk more about that when we get to some of the practice examples there. Okay, the vertex is the middle, and I'm going to put kind of that middle in quotes here, the middle of a parabola, and it's the highest or lowest point. Okay? The highest or the lowest point is basically where that curve happens. Okay? That center point is called the vertex. Parabolas are symmetrical, right? You aren't going to see a parabola that comes down like this and then jumps off like that. That's not a parabola. Okay? A parabola is symmetrical, and then it comes down, vertex, and goes back up in the same shape. And that middle point, that lowest or highest point, is the vertex point. Okay, if the point is the lowest point, that would be called the minimum point. It's the lowest the parabola goes. If the vertex is the highest point of a parabola, which you'd see if the parabola opens down, right? There, that curve happens at the top. So the vertex point is up at the top. That would be the maximum point. So if you hear those words, see those words minimum or maximum, it's talking about that vertex point, because that's the highest or the lowest. Okay? And then the axis of symmetry, it's an imaginary line that kind of cuts the parabola in half. And it's an imaginary vertical line that passes through the vertex. Okay? It's an imaginary vertical line that passes through the vertex. I'll draw an example of that in just a little bit here. Okay, so if we have our parabola here, right, the vertex down at the bottom, and then that axis of symmetry, that imaginary vertical line that passes through it, right? And it's called that axis of symmetry because if you were to fold the parabola over onto itself at that line, right, that's what makes it symmetrical. Cuts the parabola in half, essentially. All right? Lots of pictures, lots of doodling there. How are you doing so far? You feel like you've known parabolas your entire life? You're so familiar with them? Okay. Today's goal is to basically just kind of get the characteristics down of a parabola, so that when we start to graph them, we start to analyze them, we start to solve them. When we throw out words like maximum and minimum and domain and range and axis of symmetry, you know what they are and how to find them. Right. So today is kind of a technical day. This is the what. Right. This is the what. A bunch of terms to define. We'll take a look at some pictures of parabolas and see what we're talking about here. Okay, so this is the parabola that was used up at the top. And it says, for each parabola, I identified the domain and range, each written as an inequality. So we'll talk about that. The vertex, axis of symmetry, and the minimum or maximum point, which again, that minimum maximum point, that refers to the vertex. Okay, so here's our parabola. The domain of this parabola is going to be all reals, which we're not going to write as an inequality because no inequality covers everything, right? But it's all reals because if this parabola, it's got these arrows on each end, kind of like we talked about before, it's going to continue to go up in both directions, continue to get wider, which means that even though right now the x value of 3 is not included in the graph, if we continued this right side upward and expanded it, eventually we will have an ordered pair with an x value of 3, right? And as long as it continues to go out, every x value will be included at some point. How about the range, though? The range of this parabola. What y values are included in the parabola? Is the y value of 2 included in the parabola? Yes. Right? The y value of 2, there's actually 2 of them here and there are ordered pairs with a y value of 2. that is on the parabola. What about a y value of 3? Is that included? Yes. A y value of 3 has ordered pairs there and there. So 3 is included. What about 0? Y value of 0? Yeah, 0 is the vertex actually. Okay, right there. What about -1? No. There's no y value, right? If we there's no -1 y value that's included in that parabola. Will there ever be? No, because it comes down, it curves, it goes back up. How about -2? -3? -4? -5? Good guess, but no. -6? No, right? So the range of this parabola is everything what? How would you describe it? Michael? Everything 0 and above. How do we write that as an inequality? Y is, Violet, greater than or equal to 0, because 0 is included there. It's the vertex. So the range of this is y is greater than or equal to 0. And like I said, unless you're dealing with kind of a contextual special example of a parabola, the domain will always be all reals because it expands. Every x value will be included at some point. And the range will always be y is greater than or equal to something, less than or equal to something. It depends on where the vertex point is. Okay? Speaking of the vertex, where is the vertex here? What is the ordered pair? The location of the vertex, yes. 0, 0. What do we call that special point, 0, 0? What's its special name for it? The origin. The origin. I would think more like an owl, actually. Owl eyes, personally. But that's me. The axis of symmetry is that imaginary vertical line that passes through the center of the parabola, which means it passes through the vertex point. So our axis of symmetry, I'll do it in blue here, is that imaginary vertical line that happens to go through the y-axis here, but down to that vertex point. And so the equation for the axis of symmetry is where on the x-axis this line passes through. It crosses the x-axis at 0. Essentially, the x value of the vertex is going to be the equation for the axis of symmetry. And is that vertex point a minimum point or a maximum point? Is it the lowest point or the highest point, Gino? Minimum. It's the minimum point. It's the lowest that it goes. Okay? And again, it's that ordered pair 0, 0. All right? Doing okay so far? Okay. Let's go on to the next one. Here we've got a parabola that opens downward. What's the domain of this parabola? Blake? It's not really an I. It's like a double-stemmed R. It kind of does, but all reals. Okay, it continues to expand outward. It will continue to do so forever, and so every x value will be included at some point. What about the range? What y values are included in this parabola? Joe? Good. Y is less than or equal to 6. Starting at +6, everything 6 and below is part of the parabola. Everything above 6, not part of the parabola. Okay. What's the vertex point? Vertex point. James? 0, 6. Okay. The axis of symmetry, that imaginary vertical line that passes through the vertex point, what we're looking for is where does it cross the x-axis, okay, which also happens to correspond with the x value of our vertex. So just like the last one, our axis of symmetry here is going to be the equation x equals 0. Where on the x-axis does this line cross? At 0. And again, it corresponds with the x value of the vertex. And finally, is that vertex point a minimum or a maximum? Do you know? It is a maximum. Okay, and it is, again, the ordered pair is 0, 6. And so the equations that you were factoring in PO49 and PO50, when we get to graphing them, this is the shape that they are all going to make. Okay, you were working with quadratic equations without realizing it, perhaps, but the factoring piece comes up later on. It was kind of that grunt work, but this is the shape of the graph that those types of equations make. Questions on this one before we go on? Okay. Next one. Here we have a vertex that is not on the y-axis, so it gets a little bit more interesting here. But what is the domain of this parabola? Domain, what x values are included or will be included? Blake? That's not injured reserve. No, it's a double-stemmed R, all real solutions. How about the range? What y values are or will be included here? So it's someone we haven't heard from yet, perhaps. A new voice to the mix. Well, what y values? Yeah, go ahead, Drew.
Would it be y is greater than or equal to -8?
Good. Y is greater than or equal to -8, right? That is the lowest y value on this parabola. At y equals -8, that's where our vertex point is, but nothing below that is ever going to be included in the parabola. So the y values that are included are -8 and up. As an inequality, y is greater than or equal to -8. What's our vertex point? Carolyn? 3, -8. What's the equation of our axis of symmetry? Which we finally have one that's not, directly on the y-axis there. Here it is, cutting the parabola in half. What's the equation of it, Miranda? X equals 3. Right. Okay. There's a correspondence with the axis of symmetry and the x value of the vertex. There's also a correspondence, which we haven't really talked about yet because it was on the y-axis, but with the y value of the vertex and the range. Okay, these three things here are kind of all interconnected. Right? And how about that vertex point? Is it a min or a max? A min or a max? Will? It is a minimum point. Yes, it is the lowest point. And again, that order pair is 3, -8. Okay. Doing okay? Questions? Right? Okay. Let's look at the next one, because here everything seems to be going just fine until we get to one where the vertex is not exactly on an ordered pair, right? But that's okay. We can handle this because remember, the x and the y-axis are essentially just number lines, right? So our vertex point, which is kind of in the middle here, it's not, on the corner of a square. What x value does that ordered pair represent? Blake?
1.5.
Sure. We're halfway between 1 and 2. And so thinking about the x-axis as a number line, that means that we're on the ordered pair 1.5. Right? Halfway between 1 and 2. And how about the y value of that vertex there? Joey? Maybe 0.3, maybe a third, maybe 0.25, a fourth of the way. You can kind of estimate it a little bit. We'll just use 0.25, okay? But we're about a fourth of the way from 0 to 1. That represents 0.25 on the number line. So if you get a vertex that's not exactly in the corner of a square, it's okay. Just remember that you're dealing with essentially an x value number line and a y value number line. Thomas? Yes, the x value of the vertex is always going to be the axis of symmetry. Yep, that's that correlation there. And then the y value of the vertex is always going to be part of your range. right? Because the y value of the vertex is the highest or the lowest the parabola goes. You just have to figure out, which inequality symbol are you going to put in there. So I'm going to have you do the rest of this one now. And then below that, two of them that I'd like you to do yourself. Okay, so the domain for each of them, all reals. I give you the vertex point. I tell you whether or not that vertex is a minimum or a maximum, and that should tell you which direction the parabola opens, right? In connection with the range, okay, you can determine which direction that parabola opens by looking at the range and then also saying, okay, my vertex being a maximum point, what does that mean? Is the parabola going to open upward or is it going to open downward, right? So one for you to finish and then two for you to graph on your own. And these are just sketches, right? I'm basically looking for, is your vertex in the correct spot? And do you have it opening the correct direction? And is your parabola more or less symmetrical? We'll be able to get more specific in our graphs as we learn more about them. But for right now, those are kind of the three things that I'm focused on: vertex, direction, and symmetry. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms on this? Sir?
Do they have to look kind of like a parabola, or
They should look more or less like a parabola.
okay.
That is the goal. Again, it's just a sketch, so it's not perfection here, but parabolic. All right, folks, homework for tomorrow. That's IMath.